I know we did this just before 6, but we might just do this again. So you guys both work at Papercut, yeah?
Yes.
Tin and Armond. So,
Yeah, that's right. Yeah.
but do you work with Go all the time, or?
Yeah, so my main language for the last maybe 4 years probably Go. A little bit of Java here and there, and TypeScript and React, but apart from that, yeah, mostly Go.
Yeah, same here. So when I joined Papercut, I was actually an Android developer. So I was working more on the Java frameworks and the Java language. So I was doing that for about 2 years, and then I joined Tin's team. How long ago is that? It's like a long time ago now.
Yeah, a year from now, maybe 2 years from now, yeah.
Yeah, to do GoLang. I've been doing GoLang since, with a bit of React and TypeScript here and there. And occasionally having to deal with C++ code as well.
Oh, wow. Is that embedded code? Because you guys are printing, right? Yeah.
Yeah, it's actually for we have a software that intercepts print jobs, so that's currently written in C++. So every once in a while we dig into that to add more changes, but it's not as often as doing GoLang and TypeScript or React.
So it's a full stack app. Is that what you're talking about? So you've got React as the front end, and
Yeah, pretty much. Go is our back end, and all the front end is on React.
and so you guys are on the same team.
We used to, but now we are on a different team now.
Oh.
Yeah. Tin is focused more on like cloud technologies at the moment. While I'm a bit more on the low level side of things around printing.
So how many teams are there? Because there's a lot of developers at Papercut, yeah?
Yeah, I think 40 or something, maybe.
Yeah, I think it's about 40 people.
40, yeah, 40 developer, I think.
Mm. Is it really that many? It just feels like there's only 20 of us sometimes.
Because we are on level 2. There's another level actually, full of developer as well.
A whole nother level. Is that what you mean? Like multiple
Yeah.
levels?
Yeah, but then mix between like marketing and we don't call developers in our company. Well, we call like product engineer. Yeah.
Yeah, essentially developers.
Actually, do you guys want to kick it off now? You guys ready to get going?
Yeah, we can kick it off now.
Yep.
So, hi everyone, my name is Armond. I'm here with Tin, and we're both from Papercut. Yeah, so you've heard a little bit about ourselves, so probably don't need much introduction. But outside work, I'm currently playing Animal Crossing, which is a fun game during quarantine. And I'm marathoning lots of RuPaul's Drag Race episodes at the moment on stage. How about you, Tim?
Okay, so for me, yes, I'm a product engineer at Papercut. It's been 4 years already. My day-to-day work is work with Go and React. And yeah, for me, in our company, we have I play soccer as well. And we play every Tuesday, I think, during lunchtime with some of our colleagues in the company. So it's pretty cool. If you can go to like the Camberwell area, probably we can join us.
Yeah, cool. So today, as you all know, we're doing a talk around mocks in GoLang. So the way we've done this sort of presentation is to start with like very simple mocks, explain what a mock is, and then identify problems with each approach. So we're gonna start with like a very simple mock, figure out what's a problem, and then iterate as we go. And then at some point, later we'll explore different ways of improving the way we mock things in GoLang. So I guess I'll start with the first slide, which is a brief intro about mocks. I didn't really want to include this slide, but I think it felt obligatory to add, to add it here. But basically, as you all know, mocks are like test doubles. We write them in place of another external dependency for a unit of for like a certain unit that we want to test. So a lot of times when people think of mocks, it's basically just like creating some sort of behavior for a particular external dependency that we don't necessarily want to import or to instantiate or to create when testing a certain kind of behavior. So it's a controversial topic as well. Like when should we use them? Do we still use them? And do we actually need to write them? There's been lots of blog posts around whether mocking is still a thing. Personally, I think it's still a thing. I think there's this benefit to using mocks, especially when you're writing unit tests. And that's really helpful when you're just trying to test a certain behavior of a specific unit in your code without having to do too much integration with other parts of your code. So yeah, I think let's assume that mocks are still a thing. Yeah, we still need them. That's probably out of scope for now, but yeah, I think mocks have definitely been useful for us at Papercut in different ways. So to start this talk, I'd like to introduce an acceptance criteria for this presentation. This is what we'll be revolving around for the whole session. So our product owner wants this feature. They want to be able to register a user. So they want a user to be able to register. A user must have a username, and the username must have at least 5 characters. And if a username already exists, then it should fail or it should return an error. So that's like the basic acceptance criteria for this scenario. Now you won't cater for passwords and other information related to a user. We'll just assume that a user just needs a username. Yeah, we're good to go. So here's a basic implementation of this particular feature that our product owner is asking us to do. Now you might be wondering, oh no, we're doing implementation before a test. Obviously, you can also do test-driven development if you wish to. But to demonstrate some of the concepts that we're introducing today, we'll start with the implementation first. And you can, of course, do the reverse, whatever is more comfortable for you or what's more convenient. But here we have implementation of a registry. So a registry contains a database, which you can inject. Now a database basically just has 2 methods here, 2 functions. So we have a save function, you've got a get function. So the save function, as you would expect, would save a user to the database, and then get will return the user based on the username that already exists. So we've got a few very simple acceptance criteria. If the username is less than 5 characters, number of characters, then we return an error. If that username already exists in the database, we return an error saying it already exists. And then if there's an error with saving, then return an error. Otherwise, it's all pretty much done from there. So I guess that's clear. It's a very naive implementation of this feature. So let's start with a very basic test of this of that implementation. Let's say we want to test the scenario where we want to be able to test if the username is less than 5 characters. Then we want to make sure that register here returns an error. So this is a very basic test. We got registry is equal to it's creating like a new registry struct here or interface. And then when we call register with a username that has less than 5 characters, then we expect that there's an error. Of course, you can define your own specific errors, but if for this example, we'll just assume that any error is acceptable. So here we expect that if it's nil, that means that our check failed to validate the username. I'm not sure how Zoom works, Leia, but am I allowed to ask questions, or if I ask questions, can I hear people answer the questions?
Yeah, we talked about that earlier. There's actually a chat window. So if you don't have it open already, there's just down the bottom, there's a chat.
Yeah. Cool. So yeah, so that brings me to my first question. What do you think is wrong with this test? You'll see that it's a very simple test, nothing too special, but it does what it wants us to do, which is to check if a user has less than 5 characters. But there's something glaring about this test. I'm not sure if anyone's noticed, but oh. Okay, cool. But correct, yes. So Joel has raised that registry hasn't been given a database. So one thing to note here is that this test is actually quite implementation aware. This knows that because in our code, the database doesn't get called until after the username check occurs. It's not injecting the database anymore. So it's a bit implementation aware. And so which makes this test invalid at some point, especially when refactoring code here and there. What you really want to test is you want to be able to inject a proper database to this test. So let's go with that. So let's try make another test, and let's try actually injecting a database in here. So this one will be testing if a username already exists in the database, and we should fail. So here I'm using a real database, or quote unquote real. It's basically we're creating a mock database, or not really mock database, but a real database here with default values, whatever that is. And then we're creating a valid username here, which we expect not to fail. And then when we register the same username again, then we expect it to fail. So before I proceed asking with some questions, I'd like to actually introduce a new library to simplify our tests here. You notice that I have like these if error not equal to nil, if error equal nil checks. Something preferential for us here at Papercut is we use a library called Testify. Testify is from a company called Stretcher. They're a startup in the US, which unfortunately had to close down last year. I think they do like some sort of service. They provide like a service layer for data storage. They closed down last year, but what they gave the open source community is a really good library for writing tests. So I introduced that now. So you'll see here I've simplified the check here for error not equal to nil to use the require package from Testify. You can import this from GitHub. Now, basically, this just means that I require that error is nil, otherwise fail with this error message. Same with this one. I require that error is not nil, otherwise fail with this message. It's just a one-liner thing that helps simplify everything for us. But there's still something inherently wrong with this code. In fact, I could name 2 things, but does anyone want to give a guess as to what's potentially wrong in this code or problematic in this code? The .new, yeah. Yeah, yeah, that's right. So Doug says there's gonna be an issue interacting with the DB, and like as James Lee said, there's gonna be problem with using the .new here. So what is .new actually? Is it creating a real database for us? Is it gonna spin up a production database? Is it spinning up a test database? Of course, when you're writing integration tests, you'd like to actually spin up a real database, not a production database, of course, but a test database where you wanna a test database where you wanna write your integration test. But for our case, we just wanna write a unit test, and we just wanna write a unit test that tests that if a user already exists, we just want it to return an error. So we don't really need to like create a whole database here. And as Berger has mentioned, this test case is testing two things. It's starting with this test here, which validates that adding a valid username succeeds, and then tests another thing where adding the same username fails. So it's this particular test at the bottom is not particularly independent, and we want our test to be independent, so we want to split that. So before I proceed, I want to look at our implementation of the database. So this is a very naive database implementation. It's basically just an in-memory database. We've got like a users variable here, which is just an array of users. If you save a user, it just adds it to the list here. And then if you get a username, it just loops through that list and then returns the user that matches the username, the first user that matches the username. Of course, this is not going to be what it's like in production, but just to demonstrate a couple of concepts, this is what it's going to be like. So what I'll try doing now is I'll create like my own mock implementation. So this time around, I'm not going to write a real database. I'm not going to instantiate a real database. Instead, what I'll be doing is I'm creating a mock database here. Now, this mock database implements the same functions that user database expects. So we've got the save here, we've got the get here. And in this scenario, what I'm testing is that I want to test that register should error if a username already exists. So what I really want to do is I want to sort of mock the user database, make it seem as if a user already exists. To do that, all I needed to do was to create this mock user database struct. And in the get function, I return some random user here. Basically, I return a random user with the same username as the argument here. Of course, this test will pass. This test will pass because you know this is returning non-nil, and register, as we know it earlier, will return an error if this returns a non-nil. But what's fundamentally wrong? What's fundamentally problematic with this approach? Does anyone want to guess? Or something you don't like about this test? Something wrong with this test? Yeah. So Doug has mentioned this. There's a lot of code to write. That's one of the things. I can name another one actually. What else? What if, for instance, I want to test a different scenario? What if I want to test the case where I just want to test if username exceeds more than 20 lines of code? I'd have to change this code again because I can't mock it from this particular scenario. So yeah, Berger mentioned that if we have to cater for that scenario, we have to actually create a new type for each scenario. So yeah, I'm gonna do that actually because I'm too lazy. I'll just copy paste code. And what I'll do here is, so that it's clear that mock user database, what it's doing, I'm gonna rename this mock user database. So a bit more specific one. So I'm gonna name it mock user database with user already existing. It's the same code, but I'll introduce another test. This test, on the other hand, this test will test that register should error if database fails to save. So it's very similar to my previous code here, except that I've renamed it to a different struct. So this one is a bit clearer. It says mock user database that fails to save. So essentially I've created two structs now, one struct just to simulate the behavior of a username already existing, and another struct to simulate the behavior where save fails. Now, of course, obviously what I'm going for is in this scenario is that there is inherently very similar code here. That's a lot that we've written so far. So these two tests had to write two mocks just to test just to test those particular scenarios. So what I'll do is I'll refactor that code, and I will kind of what I'll do is I'll sort of put everything into a variable namespace here, so that I can mock this on my test. So here, for instance, instead of returning a specific error here, what I'll do is I'll put the save error here as a variable, as a global variable. And then for me to mock that error, I'd have to like specify an error, assign an error of a random error here, however the use case is. So at this point, cool, I can now reuse the same mockable database and simulate different scenarios by assigning different values to these three variables. So as you can see here in this scenario where I want to test the case where register should error if the database fails to save, what I'm doing is I'm just saying that save error is an error, and then the user returned on save is nil, return user on get is nil, and I should expect the behavior. But what's wrong? What's problematic with this approach? What could go wrong in this approach? Let's say you write another test. Yeah, so Don says there's gonna be shared variables. So it is potentially problematic for another test because we want tests to be independent. So you can't guarantee unless you do like a cleanup or a setup function somewhere that these particular variables are in a state where you want them to be at the beginning of your test. So it's not also well encapsulated. Now, having Java background, I want to go back to, I just want to do some random recall to Java Mockito, probably one of the most used mocking frameworks in Java. So with Java Mockito, you can do something like this. You can do something like, it's actually a code I randomly pulled from our code base. I'm not gonna get sued for this, but but it should be fine, I think. Anyway, so here I can do something like when scan action is configurable, scan action method is called, then it should return true. When job definition get job fields, then return job fields. It's kind of similar to what I'm doing here really in the previous one, where I'm like, kind of want to be able to say when mock database dot get username is called, then return something, so I can mock that specific behavior. So I'm going to introduce another library, and because I love Stretcher so much, I'm going to introduce a library called testify mock. So this is a package under a testify module, which allows you to create a mock interface for whatever database, whatever interface you want to mock for your subject under test. So in this scenario, I've got here a mock user database, and I've got the two methods here defined. Sorry. And then as before, for me to be able to test if, sorry, that's really bad. As before, for me to be able to test that if there's already a user that exists, I want it to fail. All I gotta do is I can do something like this. So in the registry, I inject the mock database, and you'll see that the mock database is created by using this mock user database struct that I've defined here, and it extends mock.mock from testify mock. And similar to Mockito, I can do something like this: mockdb.on get. So basically, it's like when mockdb.get is called with this particular argument, which is the username, then return an existing user. So yeah, it works fine actually. In fact, the tests pass, and I can even add another one. And if I want to test the same function, I want to be able to. I can just say mockdb.onSave, then return an error. But what's problematic with this approach? What do you feel is what is it about this approach you don't like in particular? Yeah, yeah, that's right. So sure, you've got these method here, these functions here, and then you've had to hard code the method name here, which is problematic if you're refactoring your code, you're renaming your methods because you can't, because if you change this, say for instance, say you change that to update or something, or put, you have to also change your tests here to put. And with a lot of IDE tools nowadays, they can't automatically detect that you have that when refactoring this, it will refactor this as well. It's a messy. It's not compile safe. So Ilya does like this approach. Instead, there's manual code writing. That's right. So there's also this annoying thing about using this library is that you actually have to write this two functions manually yourself. Basically, it's the same as the one we've written before, except that it's a bit more encapsulated within mock.mock. It's just saying, return this and that, given this and that. So what I'll do is so that's a lot of boilerplate code over there. What I'll do is I introduce another library. Sorry, I'm introducing too many libraries. I'm calling it Mockery. But I'm not calling it Mockery, it's called Mockery. This is from Vectra. Basically what they do is they provide a way to auto-generate the mocks for you. So in here, you can, given you've already installed this library, you can easily just trigger a CLI command, provide it with the interface that you want to mock, and it will auto-generate this file for you. So it will actually put it in the mocks package, but you can of course customize that to be somewhere. Now what it will do is it will automatically create this get and save function for you. So it's a bit more complicated than what we have, but I think it caters as well for cases where you want to be able to use argument captures. So cool. I can simplify that code then to just be this. I didn't have to write the mock myself with this approach. So, but I had to use Mockery for that. Obviously, with this approach, it's a bit annoying because now you have to run this. You have to run this command just to create a mock for a specific interface that you want to mock. And at the same time, you have this extra file that you have to commit into the code base. as to whether or not you want to commit it, that's obviously a team choice. You obviously may choose not to commit the auto-generated mock by using hooks or whatever to create your mock file here. So you can easily mock external dependencies onto your tests. But from here on, I'm gonna introduce you guys to Tim. Tim will show you improvements to this code, and he'll be introducing as well a couple more libraries that we can use to do mocking with our tests. So Tim.
Okay, thanks, Armond. Hello, everyone. So I will share my screen, and I will. Okay, so let me share this. Okay. So let me turn on my slide. Okay, so a little bit context about this library. And so before we do this talk, actually Armond did a tech talk about like mocking in our company. When he showed me about the mock of testify and also the mockery, and I see the hard-coded method name in the test, I say, oh, surely we can do better. I think that it's probably we should like try something else. So let's just do a little bit of research, and actually we come up with like this library. It's called Goldmock. This one is actually one of the most popular mocking framework in Go. It has been there for a while. And the idea of this library is it has leveraged the reflection and code generation to actually to generate the interface, just like the mockery tool that Armond just shown us. So this library, it actually just have two components. One is the Goldmock, which is that the runtime of the library. So you have to use this in your test. And it have another component called mockgen. This is a binary tool so that it will help you to generate the all of the interface so that you can use in your test as well. And both of them actually can be installed using the go get command. So let's say we had an interface called database, like we have before in the code that Armond showed us. And then so we can use the mockgen tool to actually to generate the interface. Mockgen work in two mode. They have the source mode so that you can specify where the source, and then you can specify the destination, what is the final package for your mock. So this one, it will use it will pass your source file into the AST structure, and then it will generate the code. There's another option is if you want to use the reflection mode, which means that you can use, and then you have to specify what is the package of the file destination package and the package of your interface, and then the final name is the interface name. So from my perspective, my users, I think the source mode is a little bit more refactory friendly. So because like you don't have to, I will show you a little bit later when we integrate this one with Go generate. So let's see. Let me switch to my IDE actually. Okay, so I already prepared some of the commands exactly to generate. So I just show you guys here. I don't have to generate; it's already generated. Let me run it to see. Okay, so here's the generated code from Goldmock. So quite a few code in here. And so let's go back to the test. So actually we can view this one. Yep. So we, as I said before, Goldmock have two components. One component is actually the runtime, which is that you have to use in your test. So in here you have to create the controller, and then you have to like close that controller, and then you create the your mock database. So this one is the generated code. And then you set the expectation just like you do with the Mockito in Java. So you say that when I call this get method, and then it will return a character a user. So it's very nice, and it's quite convenient so that you can provide your ad hoc implementation in your test. So just going to give you a little bit more background about the generated code. I think I prepared a class diagram. So let me how to use this one for the generated mock. So in this code, we have the mock database struct, and then a mock database mock recorder. The mock database is actually the struct implement your interface. So it have all of the method of your interface, and it also have a method called expect, and it will return a mock recorder. So the mock recorder, as you can see, it generate you two similar method name, but it's not exactly the method name of your interface. So so when you call your mock, and then you can expect, just like in the test here, it actually return you the mock recorder. So you have like nice in IntelliJ actually help us actually to do the autocomplete, so it's quite nice. And then we can inject the database in when we finish the test. Okay. So let me. Any questions so far? I think that is easier than the previous approach or the previous library, in my opinion. So let me. Okay. So there are some common uses for a mock library. So like we have in Mockito in Java, you can specify, you can expect how many times that the mock get called. So there's a few methods in Goldmock you can use. So essentially, the first one and the second one is the same. So if you don't specify time, it actually if specifically it's actually default is 1. And you can specify min time or max times, or if you don't care much about how many times that the mock get interact, you can just say any time. So this essentially your mock become like stop now. And yeah, and expected like any other mocking library. So you want to sometimes you want to match the argument that pass into your mock. So you want to say, let's say I want to only return or only do this when the username equal to some particular condition. Like in here, some of the default built-in argument matcher. You can match based on the content, the type, or if you don't care anything, you can just say anything. As you can see that if you the trick from the mock recorder, actually all of the method that pass into here is the type is actually interface, like the empty interface. Okay, I see that there are some chat. Okay, no. Okay, go on. Sorry. And you can like combine the argument matcher as well with the all. Or if those built-in argument matcher doesn't suit your need, you can implement a custom element matcher as well. So let me show you how to do ones. So basically this interface is the built-in interface of Goldmock. You have to implement the match method and a string method, and to make actually to match with the implementation to create an implementation of the matcher. So in here, it is just a quick copy from the length argument matcher. So if that is, if you want to define a custom matcher, I'll go back to this. And yes, so you can do provide an ad hoc implementation as well. So let's say if you want to do a return, or you want to do some fancy processing in your mocking method, you can define your own implementation. So in here that I can provide my own implementation with to do some custom logic here. if you want to. Okay, so this one, if you want to capture the argument, so the other one, the argument matcher. So if you want to match something, but then if you want to capture the argument and do something else with this, so it is just a specific implementation of the custom or ad hoc implementation. So you provide your own implementation, and then you have to assign a variable outside, and then in your custom implementation, you assign that variable, and then you can do the assertion later on in your test. I think this one, I rarely use it, but in some case, if just in case that you want to use it, you want to specify the order, how your tests, your code actually interact with the mock object, you can specify the order that they need to follow. So there's two ways. You can use either the after, so you create a call, and then you say the next one has to be after the first one, or you specify them in block in order, and then you can specify all of the code that you need your implementation need to exercise. So far that you when you use Goldmock, the workflow is you identify the interface that you want to generate, and you use the mock gen tool to generate the code. And then for my team in Papercut, we commit every generated code into our repo. But then there's a better way to actually to integrate with the Goldmock is we integrate with GoGenerate, which is the directory. In GoGenerate, your tool can actually access to some of the variable available. So let me show you how we can do this. So as you can see here, I can specify the GoGenerate directory. And then I say that, okay, so we are using the source mode. The Go file is actually the file name of this particular file, user.go, and what is the destination and the package. So when you define that, you can generate like this. And then you say go generate, basically go generate will traverse your source code directory, go into its directory, and then run this command. If it find the command, this directory inside your source code. So let me run that. It's already generated, so you can see that it doesn't have to be any change. So, but it is generated. Just assume that this one is generated. Okay, so that is the Goldmock. So there's another library which is not very popular, like Goldmock. It's called mock. And the same, it uses the same mechanism, do the code generation for your mock object, but this one is simpler, but it doesn't have any runtime dependency. So you can install using GoGet as well. So after you install, it will provide you a binary called mock so that you can generate your code. So here's the command that you generate. You use to generate your code. So you need to specify your interface. So I think that it doesn't use the source catalog mode. It's more like using the runtime mode. And so here's the generated code. So let's first take a look at the. So this is the generated code from mock. It's quite long. And here's the test that I use the generated code from mock. So you can say you want to create a mock database, and then you can provide your custom implementation for the get function, and you just inject that thing, and then you use it in your test. So yes, so this one, Armond, you want to talk about this?
Yes, so we explored a couple of different libraries for mocking and different approaches as well to just not using any libraries. But there are a couple of things that I'd like to discuss around best practices when using mocking libraries. One of the most common questions would be, are we meant to commit auto-generated files? There's no right or wrong answer to this. it will depend more as a team decision. A lot of times when you do when you do commit your code, what ends up happening is you have to commit your code for every mock interface or mock structure they have. Now, and that's also very beneficial for like new people coming into the team, because they can just run tests automatically without again having to generate everything, or without having to generate code for Go. Click team. You can also use plugins. Actually, there are a couple of plugins available for on VS Code and on IntelliJ, GoLang. They provide plugins for some libraries, like for instance Mockery earlier, which I showed. They have a built-in library. They have a library for it on IntelliJ. So if you install it, it automatically creates an auto-generated mock for you, so you don't have to run any code whatsoever. Click. And as usual, it's if you choose not to commit your auto-generated files, one thing that has worked as well for us is using Git hooks. So like when you pull code, it will auto-generate certain files for you. And you can also create a sort of like a pattern on your Git ignore, so you can ignore these generated files. But this gives you the benefit of not having to commit any auto-generated code, but at the same time without requiring to explicitly generate those auto-generated code just for the purpose of testing. So yeah, that's pretty much it. So that's what we have so far. Any questions? Tim, did you want to add anything?
I think that's it. So let me
Yep.
let me stop sharing. I think.
Oh, there's a question about integration tests. That's a good question.
I cannot.
Oh yeah, Tim.
Okay, so this is a very broad question, I think. So for testing between microservices, in the past, we try to use one of the library to do the consumer-driven contract in Go. So that library developed by SIG, and basically, that library start up a new kind of like what do you call an HTTP server. Let's say that the communication between the microservices is HTTP, and then it listens on a particular port, and then when you hit that, you specify all of the mock like in like the normal HTTP server mock, then it will generate you the interaction so that you can use that one to verify against the implementation or you can use that one. So as a consumer, you use that one in a mock in your test, but then as a part of the test run, it will generate you a spec file so that you can use that file to verify against the provider later on. But we found that it's a little bit too clunky, and it requires a lot of effort to do that. So we end up actually just do a normal mocking, just start a normal HTTP server and capture the response, just do as normal. We don't have a very good answer for this, but if you have any honest approach, I think that we love to hear.
Yeah, we've done something similar as well previously in one of our projects team, where we used Pact.
Yeah.
Pact. I can't remember who wrote Pact. It was one of the startups. It was a startup in Sydney, I think. But it was too clunky as well. It was a lot of work to set up. But it did ensure that when it did ensure that contracts between two services were being met. We ended up just we didn't really find so much benefit from it, probably because it didn't really apply to our use case so much. because our services were being written by one team. So there was better communication between developers. So we ended up just using the native HTTP test package, which is provided by GoLang to spin up a test server. Then you can stub the request and responses however you like. It provided almost the same amount of benefit we had with using verification tests.
Okay, so Berger asked a question. So why do you think a lot of mocking is so much more work than? I think yeah, it is just my opinion. I think that Go the reason I think because the type system of Go is not as strong as the other language like Java and .NET, and they have generic as well. So Go is a little bit primitive in terms of like type system. So that's why it's one way to actually to do those kind of things is fall back to either using reflection, even like the reflection package is not good either. So they had usually fall back to code generation. So, I hope that it actually answer your question, Roger.
Did you guys do this presentation internally to kind of like pitch your ideas about which mocking libraries to use across the teams or something like that?
So we are previously we don't have any mocking library, to be honest. So we end up something like the symptom that Armond said, that we had a lot of duplicated code, and people like start like copy and paste the implementation of the mock around. And then we start looking at those. So some of the team actually do, my team actually start doing the Goldmock, and I think that Armond team also start using this. So we start a kind of like a process to finalize the framework, but for now we haven't finalized yet.
Yeah, a lot of the examples I've shown earlier as well were some of the things that we've seen across different code bases, because we just couldn't find different ways to, we just couldn't find a good way to mock things. But then over time, we realized that inherently there was a problem introduced by each approach. So we had to find a way to formalize it.
Yeah, I think this is a very good question from Gustavo.
I can't see the questions now. Where is it going?
It is in chat, so yeah, I may answer this one. So I think it happened the same for all other languages, not just Go. I'm thinking in the same thing like Java, you had a very popular framework to do the testing JUnit, but then like later on you have like TestNG and some other stuff as well. So for us, I think that usually if we make it modular enough, probably we don't need to actually to switch, unless that there's a very compelling reason to switch. But for now, I think that we probably end up with like either Goldmock or Mockery or Testify. We need to decide, but from what I see, we don't have like a need to actually to switch just because of something is more popular.
Yeah, at the end of the day, it's what works best for what you're working on. Like what's the most valuable thing that you can do to make sure that there's still code quality being ensured in your code base. Like at the end, it would have to be if another library I think offers more features. I wouldn't particularly use that new library just because it has new features, but I would consider the benefit it would give the code base or to the team. If it has any features that could benefit the team that has great value.
Okay, so for Tam actually asked a question about BDD in GoLang like Ginkgo. I personally, in our project, we don't use Ginkgo. I know about it, but it Go is a little bit like not young anymore, but then the testing practice and stuff in Go is still young. So there's quite a lot of language, and in the idiomatic way Go, so they don't want to use like a lot of like a framework. So especially those kind of like PDD, they define their own DSL, and you have to learn those kind of like DSL as well. So it the same thing like so it tomorrow or next year there's another BDD framework actually go out. So we switch to that, and then we have to learn a new DSL from them. So we try to stick as close as possible. So as you can see that the mocking is quite simple, and then Go actually provide quite good default testing library already. So right now we in our company we don't use it, but then maybe in the future, but for now we don't.
I guess to that note, does anyone use any BDD frameworks in GoLang? I guess that's
I think I saw someone do a raised hand. I don't know. Can people just say in chat if they're using that tool?
oh Ilya is. Yeah. What's your experience like with Ilya? Oh, sorry, with Ginkgo. Sorry. So am I pronouncing your name correctly? Sorry if I'm not pronouncing it right. Also, Ginkgo helps with contract testing as well.
Just a counter argument. So we do use quite a few tests to Go provide subtests, and so we use subtests quite a lot, and it can mimic some of the stuff that we like kind of have in your example with the Ginkgo, like before each and those. So you don't have like before each, but then you have to kind of like build your own, and then over time you can like create a kind of like a button so that you can share with the team. But then no, those we don't build a kind of like a DSL around that. So this one is looking at nice as well, I think.
Cool. I guess that's it for us tonight. I think there's like so I know it's already 7 p.m. It's 30 minutes beyond what we've asked for. So thank you so much for coming to our talk, and hope you.
Yeah, I hope you guys will take something out from this talk. Thank you. Thank you for your time.
Yeah. Thanks, Leia, and to your team for organizing this talk for us.
Yep.
Yeah, no, it was great. It's really good.
Yeah, thanks, Leah, and the team.
Thanks, guys.